Hello, welcome back for lesson 3.4. We're still working with linear equations, but today we're going to work with linear inequalities. And we did some inequalities back in unit 2. So this should be kind of a combination of some things that we've already learned. So here in the book, question number 2 is asking us to graph the solution set for each of the following. So we want to know where x plus y is less than or equal to 5. So our class, it's important to learn the symbolics, right? The algebra with the letters and the numbers. But I really also been trying to help you focus visually in Desmos. So we're going to go there as well. Make sure you click on the link for the Desmos link in Canvas to all of this work. So because x and y are on the same side, it's kind of easy to find your x-intercept and your y-intercept, and that just helps you plot your 2 points. And then you can shade from there. So it's really not as hard as it looks. So the first thing we're going to do is let x equal 0. Okay, so when we do that, we get y is less than or equal to 5. Okay, so we're going to treat it like an equal sign for right now. Before we get hung up on the less than or equals, we're just going to say y equals 5. So we have a coordinate point that's 0, 5. 0, 5, we'll see it's right there. And then the second thing we're going to do is we're going to let y equal 0. So then x is equal to 5 in this case. Okay, so that means we have 5, 0. So then we're going to go over to the right 5 and 0. And then we're going to connect the dots because you only need two points to create a line. And we want to know where the x plus y is less than 5. So here, if you do x is 1, x is 1 and y is 4, you add them together and you get 5 or less. So it's going to be anything shaded under here. And because it's less than or equal to, we have an equal to, our line gets a solid line. Okay, so let's go to Desmos and check it out. And remember, you can just click on the circle and that turns on the equation that I have listed for you. And you can see it's exactly what we thought. Now, if I click on my line, you can see that it does give me the intercepts, just like we've learned before in the previous lesson. So there's the 0, 5, and then here is the 5, 0. Okay, let's look at the next one on our paper. The next one is 4. So first thing I'm going to do is I'm going to let x equal 0. So 0 minus y equals a -3. But we always want to know what y is when it's positive. So we're going to divide by a -1. So this is going to be y is equal to a +3. Now remember, if we had the symbol in there, the greater than or equal to, it would have flipped, right? It would have been y is less than 3. So we'll figure out the inequality symbol here in just a minute. We're just going to graph this with the equal. So we have a point of 0 and 3, 0 and 3. And then the second thing we're going to do is we're going to let y equal 0. So x will be -0 is, we're going to do the equal sign, a -3. So x is equal to a -3. So we have the point -3, 0. So we're this way this time. And it's a strictly greater than, so it just gets a dotted line. And we want to know where this line is bigger than a -3. Okay. So we want to know if we were to put in points, where would it be bigger than a -3? So I'm going to try to help you come up with different ways to test this. So on this one, let's just pick two, an X and a Y, and see if it gives me a true statement or a false statement, and I'll know where to shade. So I'm going to say, let's use a -3 and 4. So X is a -3, Y is 4. So this right here is a -3. And this is 4. So we're going to go over 3 and up to 4. So that would be right here. So I'm going to put that into my equation, -3 and 4. So that means a -3 subtracting 4, because that's my equation is X minus Y greater than a -3. So X, which is a -3, subtracting 4 is a -7. Is that greater than a -3? No, that's a false. So it's right here. So a -3 and 4 should be shaded to the underneath. Okay, because that was not true. So this point here that we plotted, a -3, 4, it's not a true statement. If we put a -3 in for X, subtracting 4, we get a -7, and it's not greater than a -3. So let's just validate that when we go and look at our Desmos graph. So I'm going to turn off my previous graph. Oops, turn that off. And then I'm going to click on the X minus Y greater than a -3. And you can see that it is shaded below, just like we thought. Okay, let's go to the next problem. So the next one we have is number 12. And the X and the Y are not on the same side. So we just need to find a couple of points to be able to graph the line. So on this one, because putting in 0 for X would make this a little simple, I'm gonna let X equal 0 and see what we get. So Y, and remember, we're going to treat it as an equal to. So Y equals 2 times 0 minus 1. So Y equals a -1. So we have the point 0, -1. So there's 1 down there. And now what if I put in 1? I'm going to let X equal 1. So Y equals 2 times 1 minus 1. So Y equals 2 minus 1. So Y equals 1. So we've got the point 1, 1 is another point on our graph. So over 1, up 1. Okay. So remember, we just have to find 2 points to be able to draw the line, and whatever X you put in, you just have to find a Y that goes with it. So here are my 2 points, 0, -1, which happens to be my Y-intercept, and then the point 1, 1, which is not my X-intercept, but my X-intercept will be somewhere in between here. And because it's less than or equal to, I'm going to draw a solid line this time. Oops, solid line. And I want to know where all my Y's are less than this line. So I think it's going to be below, because all of my Y values are less than this line. But let's pick a point over here somewhere that to see if this is true. So I'm going to pick a point that's over here somewhere crazy. So I'm going to say, what about the point 3, -4? Okay, so when X is 3 and Y is a -4. So I'm going to put a -4 in for Y. is that less than, this is my question, right? Which way am I going to shade? Is that less than when 2 times 3 minus 1? So is a -4 less than or equal to 6 minus 1 is 5. So the point that we're looking at is 3 over 3 and down 4. So that would be over here somewhere, right? And yes, a -4 is less than or equal to +5. So I'm shading this way because it made a true statement. It doesn't matter where you pick your point. So you're just picking a point to see which side you're going to shade. I chose 3, -4, and I plotted that point. And then when I put that point in for X and Y, if my statement is a true statement, then that is where I'm going to shade. If my statement was a false statement, then I have to shade in the opposite of where my point is. And it happened to be that it made a true statement. A -4 is less than or equal to +5. And so I'm shading where that point is. And we can validate this for number 12 in Desmos by clicking on that equation, and you can see that it did shade to the right below that. And this color is so pretty. Okay. Now let's go to number 14. Another one that we can put X and Y are on the same side. So it's easy to do the 2 points when X is 0, Y is 0. So one is let X equal 0. So when we do that, that multiplies to 0. And we have 3y equals 6. So we can divide by 3. Remember, we're using all of our solving skills that we learned in chapters 2 already. So just keep thinking about that. We're solving equations still. So y equals 2. So I have a point of 0, 2 is one of my points. And then my second point is going to be, I'm going to let y equal 0. So in that case, I have a -2x plus 3 times 0 equals 6. So that goes to 0. So we have a -2x equals 6. So I'm going to divide by a -2. So x equals a -3. So my other point is a -3 comma 0 because x is a -3 and we put y, 0 in for y. So a -3, 1, 2, 3 right here. And it says strictly less than, so it's going to get a dotted line on that line. And we want to know where is the line less than 6. So I think it's going to be to the right here, but I'm just going to pick a point. And, and when it makes sense, I really like to pick the point 0, 0, just because that's an easy one to put in for X and Y. So this is my checkpoint. My checkpoint is going to be 0, 0. So when I put 0 in for X plus 0 in for Y, the question mark is it less than 6? So 0 plus 0 less than 6 is 0 less than 6. Yep, check it is. So that means I get to shade. This is where it is in agreement with my inequality is at that point. So I'm going to shade everything here. And again, we can check it in Desmos. Right here. There it is, just like we thought. Okay, the next couple I'd like to look at are 18 and 20. They are in the book. They give us the graph this time. And it says, for each graph shown here, name the linear inequality in 2 variables that is represented by the shaded region. Okay, so we have to find the equation that goes with this. So we can look for, ideally, if the X and Y intercept fall at integer points, that would be helpful. So we can see that it looks like the Y intercept falls at 0, 4, and the X intercept falls at -4, 0. So that's going to help us find our line. So we have 0, 4, and -4, 0. So that will help us find our line. So we know that we need a Y equals MX plus B, right? And so it's a dotted line. So let's go ahead and find our slope. So our slope is going to be our change in Y, so 0 minus 4 over our change in X. So a -4 minus 0. So we have a -4 divided by -4 is a +1 is my slope. So my slope is 1 times X plus B. The cool thing is I know B. We found our Y-intercept by looking at the graph. So that's at 0, 4. So my equation is Y equals 1X plus 4, or Y equals X plus 4. Okay. And we said that line right there, where the Y's are, let's go and look. We've got two things we have to look at here in the graph. One thing is that it's a dotted line. So that means it's going to be a strictly greater than or strictly less than, and it's shaded above. So it's going to be greater than the line. So this is going to make this true where the Y's are greater than the X plus 4. And now we can check this one in Desmos by putting in what we think is true about we think this is the true statement that's going to make it look like the graph on page 249. So let's go to Desmos and put what we think is our correct equation, and we can check our work. So I'm going to enter it in here. We think it's Y is greater than X plus 4. We did it. Yay. It looks just like what it did in the book. Exciting. Okay, let's do the same thing for number 20. That was fun. Number 20. So number 20. Let's see if we can find two fun, cool points to work with here. So that's number 18. Let's look at number 20 script. So number 20, it looks like we have the Y-intercept at 0, 2, and it looks like we have an X-intercept at 4, 0. So we can use those 2 points to help us create our line. And notice that it's shaded underneath and it's a solid line. So we're going to remember that. So 0, 2, and 4, 0. 0, 2, and 4, 0. So our slope is going to be 0 minus 2 over 4 minus 0. So 0 minus 2 over 4 minus 0. So we have a -2 over 4. So my slope is a -1/2. And we're trying to create this puzzle, right? Y equals mx plus b. We know the slope is a -1/2, so -1/2 x. And the cool thing is we know our y-intercept, 0, 2. So it's +2. We said it was shaded underneath, so that means the y's are less than the -1/2 x plus 2. And because it was a solid line, it's going to be less than or equal to. So this should be our equation. Let's go and remember, you can always go and rewind and watch me do the problem over and over again. So here I am in Desmos. I'm gonna put in what we think is true, y, and I have to go to my keyboard so I can get that less than or equal to, and then parenthesis, it's a -1/2, and I'm putting that in parentheses to make sure it's separated from the x, and then we said +2. And let's go back and just see, does it look, it does, it looks just like the one we saw in the book. How cool is that? Yay. Okay. So just a couple more left. You are hopefully getting the hang of this. Let's look at number 24. So 24, there's no x's. So when it's just a y equals, right? We're just finding the horizontal line at y equals, oops, I should have done that here, -5. So we've got 1, 2, 3, 4, 5. And why did I make it dotted? Because this is strictly greater than. And so here's the line y equals a -5, but we want to know where all the y's are greater than a -5. So that's just going to be shading everything up here. And again, we can check this in Desmos because we're getting really good at that. And we're turning on the graph, and there it is. Okay. The next one I want to look at is number 28. This is a y is less than or equal to 1/3 x. So let's just pretend there's a +0 there, because remember that is like our y-intercept. So we know we have our y-intercept at 0, 0. That's a point, right, for us to check, to put in. Let's go ahead and put that one in. And then I'm going to be a little strategic here on my point I'm putting in. I'm going to put in any multiple of 3 so that when I multiply by 1/3, it gives me an integer. So I'm going to let x equal 3. So y equals 1/3 times 3. So when I do that, that cancels to make 1. So y equals 1. So now I have my second point at 3, 1. So 1, 2, 3, 1. So 3, 1. There's my, and it's less than or equal to. The equal to means I'm going to do a solid line. This slope is really shallow. So notice that when we have slopes that are fractional slopes, it's a very gentle slope. And when we have slopes that are bigger, so remember on this one, we had a slope that had a 2, and it was a much steeper slope. Okay, we want to know where the y is less than or equal to 1/3 x. So here's our line, the 1/3 x, and where the y is less than or equal to that. That should be everything down here. Once again, we're going to double check this in Desmos. And I'm gonna turn that on and voila, there it is. Okay, let's go back and do more 41 and 43. Let's see what 41, 43. So these are applying our concepts. It says number of people in a dance club. A dance club holds a maximum of 200 people. The club charges one price for students and a higher price for non-students. If the number of students in the club at any time is X and the number of non-students is Y, sketch the graph and shade the region in the first quadrant that contains all combinations of students and non-students who are in the club at any time. Okay. So it holds a maximum of 200 people, maximum. So we have to keep the number of people less than 200, right? So we've got students and non-students. Let's call them, S gets mistaken with a 5. So I'm going to say T will be students and N will be non-students. Right? And we want, they said the only stipulation had to be that N plus T has to be less than or equal to 200 at all times. They didn't give us any information about the price. They were just saying the prices are just different and they didn't have any restriction on money. So we're just talking about students. So it just says the maximum number of students. So we have to be less than or equal to 200. And they want us to graph this in the first quadrant. So so we're going to say this is going to be N and T will be here. So non-students and students. So we could either have 200 non-students, right? And no students. That's an option. So we could have the point 200 and 0. We could also have the point 0 and 200, right? Well, we could say, well, let's do the same here. No non-students and all students. And then we're going to just, it's going to be a solid line because it's a less than or equal to, and it says we have to keep it underneath the 200. So we need the line to be less than that. N plus T has to be less than the 200. So let's go in and put what we think is true and make sure that we shaded it and make sure Mrs. Main shaded that correct. So we think that we're going to have to say it's X plus Y because remember Desmos doesn't use N and T's. X plus Y, and then we're going to go to our keyboard and put in the less than or equal to 200. Oops, we got to turn the other one off. And because our scaling is so much different on this problem, we have to look here. Okay, so I just zoomed out up here on the top right. You can see where my mouse is. We can click a minus to zoom out so we can get the bigger picture. So yes, we're going to shade less than to the left. That one was a little tricky. Okay, the next one that I wanted to look at was number 43. So let's go back to our paper and book and just read about this one and figure out what this one is all about. So it's all about gas mileage. So it says you have two cars. The first car travels an average of 12 miles on a gallon of gasoline, and the second averages 22 miles on a gallon per gallon. Suppose you can afford to buy up to 30 gallons of gasoline this month. If the first car is driven X miles this month and the second car is driven Y miles this month, sketch the graph and shade the region in the first quadrant that gives all the possible values of X and Y that will keep you from buying more than 30 gallons. So you have to keep your gallons under 30, your X plus Y. Okay. And remember, they're giving the definition of X is a number of miles. And then Y is a number of miles. And this is miles per gallon. But this is in gallons. Okay. So this one is definitely a little bit trickier. So we need gallons plus gallons. We need to be under 30. Our equation needs to be under 30. So we're gonna call it car one. We're gonna call it, let's just say car one is X and car two is Y. Let's do that. Okay, so car one is 12 miles per gallon. Okay. It's 12 miles per gallon. But we want gallons. They said that we need to have gallons plus gallons, right? We need to have the gallons equal 30. So because we're controlled by gallons, we need to have the gallons in the numerator. So I'm just going to flip this. This is 12 miles per gallon, or we can write this as 1 gallon for every 12 miles. That's how we're going to write this. And then the car two is 22 miles per gallon. But I'm going to write it as 1 gallon. They get 22 miles. Okay. So that when I multiply the X miles, right, because X is in miles, times 1/12 plus the Y miles times 1/22, I can get them to be under, we want it to be under or less than or equal to 30 gallons. Because this is going to be X and Y are in miles. And then what they gave us is gallons over miles is their rate. So this is gallons. And this is miles. The 12 is miles. And we want the miles to cancel and to have gallons left because 30 is in the unit of gallons. This is one of the trickiest of the tricky. So hold tight. The reason I did that, because the 12 miles per gallon is just a true statement and we can write it in either way. And I chose to look at this instead of 12 miles per gallon as for 1 gallon of gas, I can drive 12 miles. And the reason I did that is because they told us we wanted to hold at the end in gallons. We wanted to be controlling by this 30 gallons. So I'm writing all of my information with gallons in the numerator. And they also told us that X is going to be in miles and Y is going to be in miles. So that means if I flip over my fraction 12 and over 1 to 1 over 12, my miles will cancel and I'll be left with the gallons that I want. So we have x over 12 plus y over 22 less than or equal to 30. Okay. Now we can multiply through. This is a practice for that multiplying through. This one, I don't know any common multiples of 12 and 22, so I'm just going to let my least common multiple be 12 times 22. So let's go to Desmos and do that. So 12 times 22 is 264. So we're going to multiply both sides by 264. So this is going to be 264 times that fraction times 264, and 30 times 264. So we know that 12 gets multiplied by 22 over here, right? We knew that already because we multiplied them by 22 to get to 264. So that cancels out to be 22. So this is 22x plus 22 goes into 264 12 times. So we have 12y is less than or equal to 30 times 264, which is 264 times 30, 7920. So there's my equation, 22x plus 12y, 22x plus 12y, less than or equal to 7,920. Wow. There is our line. Shading to the left. Very cool. So that is the trickiest of the tricky. So don't stress. We're going to do more practice in class, and let me know if you need help with anything.